Alright, so here we go. We're on to part 6, where we look at completing the activity schedule using a table. So if we're using a table for the schedule, the detailed schedule, we can do a simple project network instead of the technical one. So we wouldn't need to use a key, and we would need to be using the times in the network. So here we go. So we still need a start node because we have 2 activities at the beginning. There are 2 activities without immediate predecessors. So we need to have a dummy start node to have that unique starting point for the network diagram. Then we have A as one starting point and we have B as another starting point, since both activities have no immediate predecessors. Then activity C follows A. Likewise, activity D follows A and activity E. Then we have F, which follows activity E. G follows activities D and F. H follows activities B and C. I follows activities G and H. And here we are at the end of the network, and we have our final activity, activity I. And as such, we do not need a dummy end node, because we have a unique ending point, unique start point, unique end point. All right, so that's the diagram. Now, for the forward pass in the network, we're going to be going through that now. So activity A has no predecessor. So the start time, the earliest start time is 0. I remember that just like a relay, when the race starts, the time on the clock is 0. The earliest finish time for activity A is simply the start time plus the expected time. So 0 plus 6, that's 6. Next, we have activity B. Earliest start time is 0 since there are no immediate predecessors. And the earliest finish time is 0 plus 2. Activity C follows activity A, so the earliest start time is the earliest finish time for A, which is 6. The earliest finish time for C, we just add 6 plus the expected time, 6 plus 3, 9. Activity D also follows activity A, so the earliest start time for D is the earliest finish time for A. That's when the baton is passed. Then, the earliest finish time for D, we simply say the earliest start time plus the expected time. 6 plus 5 is 11. On to activity E, which follows activity A as well. So the earliest start time for activity E is the earliest finish time for activity A, which is 6. Earliest finish time for E, 6 plus 5, 11. Activity F follows activity E. So the earliest start time for activity F is the earliest finish time for activity E, which is 11. Earliest finish time for F is 11 plus the expected time of 2, 11 plus 2, 13. Activity G follows activities D and F. So we're looking at now the larger of the earliest finish time for these 2 activities. So activity D ends at 11, activity F ends at 13. So the larger of those 2 would be 13, so we're using 13 as the earliest start time. For the earliest finish time, it's 13 plus the expected time, 3. That's 16. Activity H follows activities B and C. So for the earliest start time, we're looking at the larger of the earliest finish times for B, which is 2, and C, which is 9. So the larger of 2 and 9 would be 9. So the earliest start time is 9. For the finish time, 9 plus 4, 13. Then activity I follows G and H. So we're looking at the finish times for G, which is 16, and H, which is 13. And we're taking the larger of the 2, so we're using week 16. For the finish time, 16 plus the expected time of 2. 16 plus 2 is 18. So that's our end time. Now, for the expected project completion time, it will be the largest, earliest finish time. So we're looking through this entire column for the largest time. In other words, the project is finished at the time when the last activity is finished. And the last activity is finished not based on the order of the letters, but based on the time that it ends. So the latest time here is 18. So that means that activity I is the final activity, and that's when the project ends, week 18. So 18 weeks is the expected project completion time. Now we want to do a backward pass. So we're starting at the end and we're working our way back to the beginning. So we're starting with activity I. And our first question is, is activity I an immediate predecessor for any other activity? So we're looking in the immediate predecessor column for activity I. So here we are, and there's no activity I in the immediate predecessor column, so it is not a predecessor. As such, right, because it's not a predecessor, the latest that it can finish would be the project completion time of 18 weeks, because it doesn't have to be completed till the end of the project. For the latest start time, we simply say 18 minus the expected time of 2 weeks. 18 minus 2 is 16. Activity H, same question. Is activity H an immediate predecessor? So we're looking in the immediate predecessor column for activity H, and here it is. Activity H is a predecessor for activity I. So the latest finish time, because activity H needs to pass the baton to activity I needs to start at week 16, the latest. So activity H needs to be finished by week 16. Right, so again, activity H is a predecessor for activity I. So activity H has to pass the baton to activity I. H finishes at activity I needs to start at week 16. So activity H needs to end by week 16. To get the latest start time, we simply subtract the expected time. So 16 minus 4 is 12. Alright, activity G, same question. Is activity G an immediate predecessor? So we're looking in the immediate predecessor column, and here we see activity G. Right, so this means that activity G is an immediate predecessor. So we see that G is a predecessor for I. So activity G has to pass the baton to activity I. Activity I needs to start by the latest week 16. So activity G has to end by the latest week 16. To be able to pass the baton at that time. For the latest start time, we simply subtract the expected time of 3 weeks. So 16 minus 3, 13. On to activity F, and we're asking the same question. Is activity F an immediate predecessor? So we're looking in the immediate predecessor column, and here we have it, activity F. So activity F is an immediate predecessor for activity G. So activity F has to pass the baton to activity G. Activity G must start by the latest week 13. So as such, activity F must end by the latest week 13 to be able to pass the baton. For the latest start time, we simply subtract the expected time of 2 weeks. 13 minus 2 gives us 11. Activity E, same question. Is activity E an immediate predecessor? And here we see activity E as an immediate predecessor for activity F. So activity E must pass the baton to activity F. Activity F must start by the latest week 11. So activity E needs to end by the latest week 11 in order to pass the baton at that time. Right? For the latest start time, we simply subtract the expected time of 5 weeks. 11 minus 5 is 6. Alright, on to activity D. Same process. Is activity D an immediate predecessor? And here we see activity D as an immediate predecessor for activity G. So activity D must end in time to pass the baton to activity G. Activity G must start by the latest week 13. So activity D, that is, activity D needs to end by the latest week 13. Right, so it needs to end by week 13 to pass the baton to activity G at week 13. For the latest start time, we simply subtract the expected time of 5 weeks. 13 minus 5, 8. We're on to C. Is activity C an immediate predecessor? And the answer is yes. It is an immediate predecessor for activity H. So activity C needs to end in time to pass the baton to activity H. Activity H must start by the latest week 12. So the latest start time for activity H is week 12. So activity C must end by week 12 to be able to pass the baton to activity H. For the latest start time, we simply subtract the expected time of 3 weeks. 12 minus 3, 9. Same process. Is activity B an immediate predecessor? And we look in the immediate predecessor column, and here it is. So activity B is an immediate predecessor for activity H. Activity B must end in time to pass the baton to activity H. Activity H must start by the latest week 12. So activity B must end by the latest week 12 in order to pass the baton to activity H. For the latest start time, we subtract the expected time. 12 minus 2, 10. And then we're on now to the last activity, activity A. Well, actually the first activity. Alright, and the same question. Is it a predecessor? Yes, it is. But it's a predecessor for multiple activities. It's an immediate predecessor for C, D, and E. So activity A must end in time to pass the baton to these 3 activities. Right, so the latest finish time for activity A, we're looking at the lowest of the start times for these 3 activities. So it's the lowest of 9, 8, and 6. So since activity E must start by 6, that's the earliest one. Right, that's the smallest time, the lowest time. Activity A must end in time to pass the baton to activity E at week 6. So activity A must end by the latest week 6, which means it needs to start by 6 minus the expected time. 6 minus 6, 0. And that's our backward pass. Next, we are calculating the slack times. Right, so the slack time, let's go through quickly. So it's the latest finish time minus the earliest finish time. So LF minus EF. So for activity A, 6 minus 6, 0, or we could also say the latest start time minus the earliest start time, which will be 0 minus 0 to give us 0. It's good to do both calculations because if we made an error either in the forward pass or the backward pass, this should be able to pick it up for us. Alright, next, activity B. 12 minus 2, 10, or 10 minus 0, 10. Activity C, 12 minus 9, 3, or 9 minus 6, 3. D, 13 minus 11, 2, or 8 minus 6, 2. Activity E, 11 minus 11, 0, or 6 minus 6, 0. Activity F, 13 minus 13, 0, or 11 minus 11, 0. Activity G, 16 minus 16, 0, or 13 minus 13, 0. Activity H, 16 minus 16, 16 minus 13, that's 3, or 12 minus 9, also 3. And finally, activity I, 18 minus 18, 0, or 16 minus 16, 0. So we have our slack times. So we can now jump straight to our critical path. And for the critical path, we need to identify for each activity if the activity is critical or not. So remember, the critical path is the activities with a slack time of 0, also representing the longest pathway through the project. So activity A, 0, yes. B, no, 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 yes, 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 no, yes. So identify those with 0 as yes. So we can now state our critical path as activity A to activity E to activity F to G and then to activity I. So we have our critical path and it's all done to the table. Alright, so again, practice until you achieve perfection, which is just a lot of little things done well. Alright, blessings. Thank you for watching. Please subscribe for more content. Alright, all the best.